All right, let's go ahead and get started. So again, hello and welcome to today's webinar presentation, How to Choose a Time Series Database and Get Started Fast, brought to you by InfluxData. I would like to introduce you to our presenter today, Al Sargent. Al is Senior Director of Product at InfluxData, the leading time series data platform. Previously, he co-founded cloud computing pioneer Sauce Labs and has led product teams at New Relic, VMware, Pivotal, and other cloud software companies. Al has a BS in symbolic systems from Stanford University and an MBA from UCLA Anderson, and a US patent for software monitoring.
Thank you, Drew, for that introduction, and thanks everyone for joining today. I'd like to talk to you about how to choose a time series database and get started fast. And so let's go ahead and dive in without further ado. What is a time series? What is time series data, and how is it different from other data that you might have worked with, such as relational data? And so time series data is quite simply, it's a sequence of data points where you have successive measurements made over the same source over a particular time interval. And so these measurements could be things like the CPU utilization for a server, or the blood pressure through a heart rate monitor, or oil pressure in an oil rig. Whatever it is, it's some kind of measurement being checked over time. And quite simply, we're plotting the points on a graph, and your x-axis is time. Quite simply, we work with this data all the time. We're pretty familiar with it. And so it differs from the rows and columns that you might have in a relational database. So an example, for instance, you might have weather conditions where you have where you're plotting temperature over time. Another example might be stock prices, where you're pricing the value of a stock over time. And of course, that time range can vary from, the last hour, last day, year to date, or even a decade or more. Another example could be server monitoring. So the amount of disk space used, the CPU load, the throughput of the server that's going through in terms of network traffic. Or from in terms of measuring heartbeats, checking that and making sure that, seeing how the patient is doing and looking for certain types of heartbeat irregularities. Again, looking at that over time. Now, all the stuff that we've talked about are, are measuring at regular intervals, right? Where we're checking the server once a minute, checking the heartbeat once a second. But what about something like a server log, where you're checking for events that happen on a server, and you don't know how often they're going to happen? You could get 100 events in 1 second. You might get one event per minute or one event per hour. And these can be things like a page that a web server is serving up, or a user accessing a certain portion of your application. These happen at irregular times, and they're also largely text-based. Or another type of data. So I guess the point is that server logs also are a form of time series data. Even if they don't come neatly in terms of measurement value over a certain timestamp, you can still pick out certain types of measurements when you parse through a log file. So for instance, if you have a log file for, let's say, an Apache web server, you might track the return code. Is it a 200 return code, which is good, a 301 redirect, a 500, which is bad? And you might be tracking those values over the timestamp that we see here on the left-hand side of each of our server logs. So you can get time series data out of log files. Another type of time series data that might not be immediately intuitive are application traces, where for each piece of code in your application, you're tracking the timestamp of when a particular user first ran that piece of code, and then a timestamp of when they left that piece of code. So for instance, render my shopping cart page on my application could be this top bar right here. And then that shopping cart rendering piece of code might call other pieces of code. It might call a piece of code to say, well, get the list of items in the shopping cart, get the prices in the shopping cart, get the tax information get the shipping information, things like that. Those all might be separate modules of code, each with their own entry point and their own exit endpoint. And they're all linked to each other so that you can see like, okay, this piece of code calls that piece of code. So this too is a form of time series data. And it's a little bit more complex because you have these entry timestamps, exit timestamps, and then child identifiers as well for child pieces of code, each with their own entry point and endpoint. So this too is data. Now the difference between the stuff we talked about at the first part of this presentation, where you have your server monitoring or your heartbeats or your stock prices versus log files and traces, is that the former on the left here comes at regular intervals, and the latter, logs and traces, come at irregular intervals. You don't know in advance when a user is going to access your application. You don't know in advance when a certain entry is going to get written into your log. And so one of the key things to look for in a time series database is the ability to handle both regular metrics and irregular events. And so again, this is the key thing to look for. Metrics are at regular time intervals, events are at irregular time intervals. And again, it's crucial to have a time series database that can handle both. Another key thing to keep in mind is it's important to look for a time series database where you can summarize or roll up or downsample. All those terms mean basically the same thing, your irregular events into regular time intervals. So for instance, you might want to summarize the average trade price of a particular stock, which is those trades are coming in at various times of the day. You might want to summarize that into 10-minute buckets, right? So you go then from irregular events where the trades happen at any given time to regular types of bucket summarizations. Or moving from, let's say, the financial services world to monitoring world, you might want to look at the average response time for requests in an application over 1-minute intervals. And again, this is really crucial for being able to find signal out of the noise of all these irregular events that are happening. So you can start to understand what are the general trends that we're seeing in my time series database. So given that explanation of the nature of time series data, what is a time series database? So all the data obviously is timestamped, and it can have multiple timestamps. It could be, when we saw the traces, we saw both an entry timestamp and an exit timestamp. But quite often it has just one timestamp. When did the measurement occur? Again, it can be regular, irregular time periods. And a really key thing, and this is the third bullet, but it probably is the biggest differentiator, and I really want all of you to understand it, is the huge volumes of data that you see with time series data. So if you think about it, if you're monitoring a server and you're checking, let's say once, you're collecting metrics once a minute on the CPU utilization, the network throughput, if you do the math, 60 minutes in an hour, 24 hours in a day, then in one day you're going to get about 1,400 measurements coming in for just one particular server or Docker image, Docker container instance, etc. If you're checking, let's say, a patient and you're measuring their heartbeat once a second, 60 seconds in a minute, 60 seconds an hour, 24 hours in a day, you're talking about 80,000 measurements for just one patient. So now, why do I say that? Well, compare this to, let's say, relational databases. What typically goes in relational databases? Financial transactions, orders, things like that. If you're going ahead and you're buying something on your credit card, you might buy 5 or 10 items a day, right? You go out for lunch, you go out for coffee, you've got your Netflix subscription, a handful of different things that you're buying. So you might have 5 to 10 entries in your relational database per day, as compared to a patient being monitored, with their heartbeat. That's 80,000, right? So we're talking 10,000 times more writes with a time series database than with a relational database. So the data volumes are huge. One more example, I think hopefully drives home this point. For all of Stripe, the credit card payments processor. For all of Stripe worldwide, they process 5,000 credit card writes every second. Great. When you look at Wayfair, the retailer of home furnishings, they'll do at their peak during the Cyber Monday, they'll do about 1 million time series data points per second. So all of Stripe, huge payments provider, 5,000. Wayfair, 1 million. So again, the volumes of time series data is orders of magnitude bigger than with relational databases. And this is why it's really crucial to look at a purpose-built time series database. And also the data is real time. Obviously, if you're looking at a patient with a heart monitor and something starts to go awry, you want to go ahead and act on that right away. Whereas, if it takes a minute or 5 minutes for your credit card purchase to go through, not a big deal. As long as it goes through accurately at some point in the during the day, that's fine. So the data with time series data, the data with time series databases has to be acted on in real time. Or if your server goes down, right, that too needs to be operated on. Or if a particular trade price, stock price goes up to a certain level, you might want to automatically execute a trade. All of this stuff all this data is very much time sensitive with the time series database. So we work really, really hard at making our data pipeline from ingest to being able to make the data queryable, down to a second or less. So time series databases are purpose-built for collecting and storing and retrieving time series data. And this is different from other databases where you might have document databases like MongoDB, which are optimized for processing JSON documents. Search databases like Elasticsearch, optimized for full text searches, or traditional relational databases, Oracle, MySQL, Postgres, and that's all for relational data. So it's not that that Mongo doesn't have a place, or Elasticsearch doesn't have a place, or Postgres doesn't have a place. It's just you use different databases for different types of data, and time series having its own place. And we've seen, simply because with so much, there's such a big trend towards observability, where you want to have very broad collection of metrics across all of your apps and all the infrastructure they run on, and very deep, so you can dive deep to find the root cause when the problem occurs. Observability has been driving a lot of growth of time series databases, where you store all of your performance and availability metrics in a database, and also IoT, Internet of Things, where pretty much anything made, any kind of surface, is getting instrumented with a chip, a battery, and a radio to collect metrics about it, whether it's anything from a piece of packaging to a plot of farmland to individuals with their Fitbits to cars. All of these things that are manufactured are starting to emit time series data. So this is why we're seeing this tremendous growth of time series databases in terms of usage that we've seen. This is DB engines. They track the usage across many different types of databases, both commercial and open source, across many different categories. So let's talk about different use cases. So there's 3 primary use cases for time series databases. There's IoT. We talked about that. That could be anything from factories, oil and gas, smart roads, smart cities, infrastructure. And then on the consumer side, you have wearables, consumer devices and trackers, home furnishings, etc. We have DevOps monitoring, and of course, being driven by observability, where you're tracking servers, virtual machines, Docker containers, applications, users, or events. And then you have real-time analytics, where you have things like in healthcare, tracking patients, in financial services, tracking stock prices. We have it's being used in research by CERN around nuclear physics, or in astronomy, tracking star positions. All kinds of stuff in terms of real-time analytics, where you want to look at something outside of a particular device, outside of a particular piece of software, where you're trying to understand more about that piece of the world. So one good example in terms of IoT monitoring, NASA, we help them with monitor launch vehicle performance in half-second intervals, making sure that those launch vehicles are performing as they're expected to. Obviously, that's very much a real-time use case if something is going wrong with a rocket. you want to know about that right away. Capital One, DevOps monitoring, making sure that their credit card processing is always working well and that the infrastructure that their credit card processing works on works reliably 24/7. And then Wayfair, we talked about that. What Wayfair does is during Cyber Monday and the other big holiday shopping times, what they'll do is they'll track end user performance response time. So in other words, from the time I click on a link in the Wayfair webpage to the time that Wayfair webpage is completely rendered, what is that entire time? Net of network performance, net of CDN performance, net of backend server performance, net of browser rendering performance. What is that? And so by doing that, Wayfair can ensure that all of their users are having a good experience on their site. And this will, when they aren't having a good experience, they can do faster root cause analysis to figure out, well, is it a particular browser that's causing this issues, particular CDN, particular piece of backend code, what is it? So now let's get to the meat of the matter. How do you choose a time series database? And we're going to talk about this in terms of three general categories of requirements. First, how do you accumulate the data? Second, how do you analyze that data? And then finally, how do you act on that data? So let's dive into the accumulate piece. So one key requirement is the ability to ingest from a wide range of data types, regular events as well as irregular events, as well as things like logs and traces. You want to have that. You want to have a database that's flexible enough, because there are some databases that only do logs. There are some databases that only do traces, and there are some databases that only do regular events. They can't handle irregular. They can only do regular metrics. They cannot do irregular events, and so it's crucial to be able to handle across this entire range. So you have that flexibility. So you have one place where you can go, one database that you need to maintain as opposed to multiple. Another key thing is to look for a time series database with a wide range of data sources. So when you get into whether if you're doing DevOps monitoring, what you'll find is that there are so many different types of things you need to monitor. Different types of servers, web servers such as Apache or Nginx, database, other types of databases such as MySQL and Postgres, application servers, messaging servers, different types of operating systems, all kinds of stuff. And one of the great things about InfluxDB is our open source agent, Telegraph, has 200 different data sources, being able to pull from a wide range of application infrastructure. Telegraph can also pull metrics from FluentD, and FluentD has several hundred different data sources that it supports. So between the two of these, you have literally several hundred different data sources you can pull from and different types of app infrastructure you can monitor. Prometheus has gotten a lot of attraction, a lot of attention. So too is OpenTelemetry. So both of these you can pull data into InfluxDB. And so what you get is you get a very broad set of observability across all of your applications and the infrastructure they run on. So let's switch from DevOps monitoring now to IoT. Again, with IoT, there is a broad range of different protocols that you need to pull in data from. You might pull in from MQTT, you might pull from OPC UA or Modbus if you're in more of the industrial space. If you're in more of the consumer or wearables space, you might, or smaller projects, you might look at Apache NiFi, OpenHAB, or Node-RED. You want a database that can pull from time series data from all of these different data sources. And if you're building your own custom application that uses this time series data, you want to be able to work in your language of choice. So with InfluxDB, you have client libraries maintained for Python, JavaScript, Go, Java, C#, and several other different languages. So you want to be able to pull from a wide range of data sources, and that's something that InfluxDB allows you to do. Another key thing is to be able to enrich this time series data. So think about if you're doing IoT, right? And let's say you're monitoring different vehicles, different cars that are driving around on the road, and you have cars with different types of makes and models and years. When you write each of your lines of time series data, you don't want to have to repeat. This is coming from a this make of car, this model of car, this model year of car. You don't want to have to do that because that would add up to a lot of storage, a lot of repeated data. So it makes sense to store your metadata, make, model year, in a relational database, and then have simply the vehicle ID number written to your time series database. So vehicle 1234, and then be able to look up vehicle 1234 in your relational database and say, vehicle 1234 has this make, model, and year. So doing this requires you the ability to join your time series data with your relational data. And this is something that, and the thing is that a typical company won't just use just Postgres, for instance. They'll probably use Postgres and MySQL. They might use a bunch of different types of relational databases. And so it's important to have a time series database that can go ahead and join from a wide range of relational databases. And that's what InfluxDB allows you to do. It covers, as you can see here, many of the most popular databases: Postgres, MySQL, Maria, SQL Server, Oracle, and so forth. Another key aspect is to support rapid ingest. And when you look at some of the, when you look at our track record, you'll see CERN, the nuclear physics lab based near Geneva, Switzerland. They'll generate about 3 terabytes of data per second that needs to get ingested into InfluxDB. And InfluxDB, they have an InfluxDB cluster, a couple thousand nodes that'll very easily ingest this massive amount of data that they get from their nuclear physics experiments. We mentioned Wayfair with 1 million metrics per second during Cyber Monday, from looking at all the end user metrics across all their end users, making sure that every user has a great experience during the most busy shopping days of the year. Now, switching from accumulating data to analyzing the data, it's really crucial that when you look at a time series database, to make sure that you have a time series database that doesn't just pull in the data, it doesn't just store it, but also gives you a way to visually explore the data so you understand what you're looking at. And so that's one thing we provide with InfluxDB. We give you a built-in data explorer where you can very easily click on the different buckets that you're pulling data from, click on your different measurements, click on different fields in that measurement. So we can see here, we're looking from our plant buddy bucket. We want to pull in metrics on humidity, light, moisture, and so forth. And then each field, such as air temperature, humidity, and so forth, we're pulling, and we can go ahead and plot these things over time. And if we want, we can apply different aggregate functions, such as mean, median, max, min, the sum, etc., and be able to do this in a visual way that doesn't require code. But if we do want to drop into the code and get more advanced, we can click on the script editor button and do so. And all this is built in. It's not a separate tool that you need to install or source. A lot of time series databases will kind of require you to install a separate tool to do this. And that's just one more thing to have to source, set up, maintain, keep up to date, etc. Another key thing is giving you the ability to do built-in data processing, where you're doing things like downsampling your data or enriching your data, and have that built right into the product. And so one thing we do with InfluxDB is we give you these built-in tasks that run on a regular time period. In this case, in every 5 minutes, we're basically downsampling our data so that we're looking at the median response time for a particular piece of our application code. Again, not a separate thing that has to get integrated, not a separate service like like an AWS Lambda that we have to turn on and somehow connect with our time series database. It's just built right in. And then again, that allows you to have just much less setup time and much less maintenance time. Another key thing is the ability to analyze your data through notebooks. And so one of the things we've done with InfluxData is we deliver notebooks in the product itself, kind of similar to a Jupyter notebook, that's very popular in machine learning circles, where you can do things like say, here's my visualization, here's a scripted downsample, here's what the data looks like after I've done that downsampling. And the reason this is so necessary is that oftentimes you get what in an organization something we call dashboard rot, where someone creates a dashboard and it's kind of a black box. You don't know how it was created, you don't know why the data was created a certain way, and someone will create this dashboard. It'll run happily for some number of months or years. Then that person leaves the organization, and when they leave the organization, all the tribal knowledge they had that went into creating that dashboard is gone. And so people aren't quite sure what the dashboard is exactly saying, or can they trust it, or what's the analysis behind it. And so notebooks basically work through that analysis in a step-by-step process. You can add in annotations to explain your steps. And so as a result, people understand why the data was calculated a certain way. They trust the data much more to make decisions. And so even if somebody leaves the organization, they realize why there's documentation around the analysis, why it can still be trusted. So you don't get this notion of dashboard rot. You can trust the data and trust the analysis. Another thing to do that's really important to look at in terms of time series databases is to provide a range of languages to work with analyzing your data. And so it's really important to have a SQL, to be able to use SQL or a SQL-like language that you can use to query your data, but not be locked into the constraints of SQL. So one of the great things about SQL, it's familiar to many database administrators. You can use it for querying data, but you can't use it to transform your data. So you can't use it to, let's say, downsample the data. You can't use it to enrich the data, and you can't really extend it with new types of functions. So SQL is great, very, very easy on-ramp, and wonderful for getting started. However, when people need to get more power and they're willing to make that investment in learning a new language, what InfluxDB does is it provides something called Flux, which has a pipe syntax very similar to Unix cell. This feature, pipe to that feature, type to that feature, and it allows you to do a couple things given this syntax. First, it allows you to query data like SQL, but also transform the data, downsample it, enrich it, do things like look at overall equipment effectiveness, which is really popular in IoT, and you can extend it with functions. You can extend it with geotemporal query capabilities. You can extend it with overall equipment effectiveness, all kinds of different, or things like Bayesian probabilities, all kinds of things that you can do to really make your data much more easily analyzed. You can do with Flux. So it's important to provide this capability, this choice, easy on-ramp, simple and easy on-ramp like SQL, or more powerful, more extensible like Flux. Another key thing is be able to deploy your time series database across a wide range of different platforms. So whether it's small, lightweight IoT devices like Raspberry Pi or Arduino, developer laptops that might be running on Mac, Windows, or Linux, or a wide range of cloud providers or cloud infrastructure, such as AWS, Azure, Google Cloud, or infrastructure you might manage yourself, such as Docker running on Kubernetes. Moving on from analyze to act, it's important to have built-in dashboarding. Now, there are popular dashboard tools such as Grafana, and InfluxDB supports them. Our engineering team works really, really well with the Grafana engineering team. We have a great relationship with them. However, that's one more thing to have to set up. And so one thing that our customers have asked us for is, hey, can you build dashboards into the product itself so I don't have to set up and maintain and connect a separate dashboarding tool? So we do that. We provide dashboards right inside of InfluxDB, and you can create very rich dashboards with different variables that you can choose from to do different queries, set your time range, set your time zone, add explanatory notes. So this kind of rich functionality, we provide that automatically. It's built in, so you don't have to set it up yourself. It's also important to have a broad range of alerting notification checkpoints. So we allow you to do that with InfluxDB. Again, it's built right in to the Flux language. So you can do things like send alerts out to popular messaging tools such as Slack or Microsoft Teams, popular incident management tools such as PagerDuty, monitoring tools such as VictorOps, email messaging such as Twilio SendGrid or Amazon Simple Email Service. And if you want to extend your own applications, you can do so easily using things like Pushbullet and webhooks. And then also another thing, we're going to look at this in the demo in just a moment, pre-built templates. One of the things when you look at some monitoring tools, they do a great job of being able to, out of the box, provide, you pointed out a web server or a database or an application server, and you do that, and then boom, it automatically knows like, oh, I'm pulling data from MySQL. Here's a MySQL chart that'll automatically start charting. And so one thing we introduced last year was with InfluxData was we realized that we had to provide a really good out of the box experience with sort of these automatically so you could go ahead and you say, okay, we're pulling data where we're monitoring, let's say Apache JMeter. Let's go ahead and once we pull in that JMeter data, let's make it really easy to put that into a dashboard or have downsampling tasks or have alerts being created. So we created this notion of templates where you can go ahead and with one YAML file, one text file, you can define, hey, these are the data sources I'm pulling from. These are the dashboards that make sense for those data sources. Here are the tasks we can run. Here are the alerts we can run. So all of that information is encapsulated into a template. And we now have around 40 or 50 of these different templates, and they're growing more every day. So you can see a couple of them here for Apache JMeter, for AWS CloudWatch, and so forth. And we'll see a demo of this in just a moment. Another key thing are outbound integrations. Again, some time series databases and some monitoring tools really fall short in this area where they might, say like, hey, you can only pull out, 100 measurements per minute. They're really trying to be sort of the Roach Motel of data where data gets in, but you can't pull it out. And that very much is not our philosophy with InfluxData. You can put data in at millions of metrics per second. You can pull metrics out at millions of metrics per second. We are very much not the Roach Motel. So what that means is, again, we have a really strong relationship with Grafana, really tight integration where you can you can use Grafana to write queries with both InfluxQL, our SQL-like query language, as well as Flux. And that connector is built into Grafana. There's nothing separate there's no separate plugin that you need to install under Grafana. Telegraph, in addition to pulling data in and transforming your data, it can also send data out, not just to InfluxDB, but to actually many of our competitors. You can send data out. Again, we very much are customer-centric, and we realize that customers aren't going to use one monitoring tool or one time series database. And so it really makes sense to be able to allow Telegraph to be able to distribute this time series data wherever it makes sense for our customer. Also, with machine learning and big data analytics tools, we have integrations with Jupyter Notebooks, Apache Zeppelin, Pandas Data Friends. And then to pull data out, you can use our client libraries. Again, Python, JavaScript, Go. So these client libraries allow you to put data in and pull data out of InfluxDB. So this is a summary of all the different requirements that you should definitely look at. Again, around accumulating the data, analyzing the data, and acting on the data. So I hope that was helpful as you look at the time series database space. And one thing I want to really be clear on, if you look at other time series databases, they might sort of zero in to just a speeds or feeds type of question, like, hey, we could do this many metrics per second, or query this many metrics per second. And yes, InfluxDB, look, we have no problem with 3 terabytes a second at CERN or 1 million metrics a second at Wayfair. And with our IOX project, we're working at getting performance even better and getting cardinality even better, where we go from several million, where we go from cardinality of millions or tens of millions up to essentially unlimited levels of cardinality. So we're scalable and getting even more scalable, but there's a whole lot more than just number of metrics per second, number of queries per second. And it's really important that you look at across all of the different requirements that we've outlined here. So with that, without further ado, let's go ahead and talk about how we can start to get going fast with InfluxData. So all right, so what I have here is a brand new InfluxData installation. Actually, not brand new, but we're going to basically, we have InfluxData, and what we want to do is I want to start monitoring my Mac. And so, as you can see here, we do not have any dashboard around monitoring my Mac. Okay, we have something for website monitoring and so forth, but nothing around monitoring my Mac. So what I'm going to do is I'm going to use a template. And we see here, if I go into settings, templates, we have one for monitoring network interfaces, but we don't have one for monitoring a Linux or Linux-like system. So what I'm going to do here is I'm just do a simple Google search. I type for InfluxDB template, Telegraph, Linux. So click on that, and I see my Linux system monitoring template. And this explains the dashboard that we're going to set up. Now, normally, if I want to create this own dashboard from scratch, I'd have to write queries and I have to configure each cell of the dashboard, but we're going to get this set up in just a couple minutes. So what I'm going to do is I'm going to look at, I have this YAML file right here. I'm going to copy this YAML file, and let's just take a quick look at it. It's so pretty much human readable. It talks about each of the different cells that I have, different colors, different Telegraph configurations, all bundled into one text file. And because it's one text file, I can easily store this in if I wanted to, in a Git repository. I can use GitOps to track changes across all my members of my team. So what I'm going to do is I'm going to take this YAML file and going to paste it right in here, place the URL of the template's resource manifest file, click up lookup template, and now we see that it found all these different items. It found one dashboard, Linux system. And again, we'll use this to monitor different performance indicators of my Mac, the CPU, memory usage, disk, and so forth. We see we have the Telegraph configuration for Linux system monitoring. We have one bucket called Telegraph. We have different variables, so we can choose the bucket, we can choose the Linux host. We'll only have one host, but if I wanted to look across a fleet of Linux servers, if we were using this on a data center, we could use that. And then different labels. So this helps when you're searching for different types of metrics and you want to find things quickly. So install the template, and boom, it's installed. Okay, great. Now let's go to our data source and let's look at Telegraph. And we see this is what we just installed, Linux system monitoring. So setup instructions, okay? So the first thing we have to do is install the latest Telegraph. Okay, well, let's go ahead and do that. Telegraph is super easy to install. And to install it, I just have to write brew. So on a Mac, brew install Telegraph. If you're not familiar with brew, you should definitely get it. Just go to brew.sh and it'll tell you how you can install Homebrew. And you can see here, we're downloading Homebrew. And we have package managers for other types of Linux as well. So good, we just installed this. Wonderful. Okay, now let's go on to the second step here. Let's go ahead and we have to configure our API token. So generate new token. Okay, and it ends in UBG. Okay, so we're going to copy this to the clipboard, go into my terminal, export, ends in UBG. That's good. Now I'm going to go ahead and look at my environment variables. We see here, influx token. Let's make that a little bit bigger. Okay, and we see it ends in UBG, so we're good. We got the token. Okay, wonderful. Now let's go ahead here and we see start Telegraph. So we're going to run this command, and let's take a look at this command and parse this out. So we're going to run Telegraph. We're going to pass in a configuration, and the configuration is going to get served up from this subdomain. So InfluxData.com, our Cloud 2 subdomain, and this is run on AWS US West. And then we can see what's happening is that our Telegraph configuration has a secret URL, basically identified by this GUID right here. Okay, so that's what we're going to do. Okay. So let's copy this command. And that ends in 000, so we know we got the right one. And good. So we see the Telegraph 117 is started. We see it's loading these input plugins, so the plugins for CPU, disk I/O, and so forth. And we are outputting to InfluxDB version 2, which is our cloud, our multi-tenant cloud. We see that our host, my host name is this number here, and good, it seems to be running and collecting metrics every 10 seconds. Wonderful. So let's go ahead, and now we can go and we can look, and here's a new Linux system dashboard. We can see that it was created 3 minutes ago. Okay, that's good. And if we look at it, we should start to see some metrics. Now we need to pick our bucket, which is going to be Telegraph. That's what was specified earlier. And we see the host is automatically picked out, and we see that the metrics are just starting to come in. They just started to come in 43 minutes after the hour. It's 44 minutes after the hour. So yeah, we're just starting to collect the data. So boom, there we go. We're now monitoring very easily with just importing one YAML file, running a couple commands in our terminal. We've got a complete dashboard for monitoring our local developer laptop. And there's a range of other different dashboards that are out here. You can take a look at some of these. If you look into InfluxDB templates, you can see that we have templates. We check out the template gallery here. You can see we have templates for Apache JMeter, people, and these are built by the community, right? So we have stuff for League of Legends, we have AWS CloudWatch. So we have stuff that's both, you know, on the serious side and the not so serious side. CSGO, game tracker, COVID-19 monitoring, DigitalOcean billing, Docker monitoring, Raspberry Pi for Enviro Plus, Fortnite, HA proxy, etc. So a bunch of different monitoring templates to help you get started quickly. And the great thing about these templates is that you can create them. You can have one person in your organization create them and then share them with other people in your organization. All right, so we've got 15 minutes till the top of the hour. That concludes the presentation and the demo. Let's go ahead and zip it back to the Q&A section.
Awesome, thanks, Al. And like you mentioned, we do have 15 minutes for Q&A. So please submit your questions to the questions panel, and we will get to them shortly. And without further ado, let's go ahead and get started. So Al, the first question we've got for you is, why not just use a relational database?
Yeah, so I think it really comes down to the volume of the data. If you look at your relational database, they're designed for different purposes. They're designed to first of all, not handle a massive, pardon the term, influx of data, but for a much lower volume of data. Again, it goes back to look at Stripe, right? 5,000 credit card transactions per second. That's great. That's impressive, but that's nothing compared to 1 million metrics per second that you get at Wayfair. So time series data inherently has a much higher volume. However, the time series data is not as complex. You know, it's every line of time series data is essentially in the format of you've got a timestamp, you've got a measurement name, you've got some measurement values, you have some tags. Pretty simple, pretty straightforward, right? Whereas with relational databases, you have rows, you have columns, you have foreign keys, you have primary keys, you have different types of constraints, and so with relational data, it's a much more complicated semantic graph of that data. However, the volumes are much less. So with a relational database, it's simply a different use case. You want to make sure that your data is kept very precise. You know, for instance, with a relational database, if you miss a financial transaction and that financial transaction is your paycheck, that's a big issue. Whereas with time series data, if you're monitoring a Docker container once every 10 seconds and you miss one of the measurements, it's not the end of the world, because 10 seconds later, you're going to get another measurement. So time series data, so the constraints in terms of some of the constraints are relaxed with time series databases, but you get a much higher volume of data. So it's simply a purpose-built data for a different use case. That was a
Awesome.
good
That
question.
seems good to know. Okay, we've got another question here from the audience is, first of all, does InfluxDB have a Windows installer?
Does InfluxDB have a Windows installer? Not yet. We are working on that. That is on our roadmap, and we expect to have. Well, let me back up a second. So let's clarify. So with InfluxDB, you have both the core database itself and you have Telegraph. So with the core database itself, we don't yet have a Windows installer. We are working on it, and we expect to have that Windows installer available sometime later this year. Could even be as early as the first half of this year. The reason is that when you go from using a Unix or Linux or Mac type of or ARM type of installer to Windows, things are a lot different. But anyway, we expect to have one later on this year for the core database itself. For Telegraph, yes, we already do have the ability to run Telegraph on Windows. And so if we just do a quick Google search for download Telegraph, I'm assuming you can still see my screen.
Yes, we can.
Yeah, great. So okay. So here we are, and okay, so you can see with Telegraph, if we want to get the latest version, you can see these different types of things. So we use the homebrew installation for Mac OS. You have other ways to go through Docker, different package managers for Ubuntu, Debian, Red Hat. And we do have for Windows binaries right here. You can use wget and then unzip and then install from there. And so yes, we do have that. And then if you just do a quick Google search for install Telegraph on Windows, you can see that we have a number of different types of documentation that you can see here. Different blog posts, different pieces of documentation, and so forth. So yeah, great question.
Cool. It's cool that that exists, and it's promising that in the near future that there will be a Windows installer out for the database itself.
Mm-hmm.
And let's get to another question here. And this one reads, can you persist Java collections of arbitrary objects?
Can you persist Java collections of arbitrary objects? I would say no, that's not really what we're looking to do. When you look at, let's dive into what the data format looks like for time series data. Again, it's very simple because it comes in really fast. So our data format is something called line protocol. And when you look at line protocol, so it looks like this. You have essentially a measurement name. You have a so measurement name could be something like it could be Docker internals. You have a set of tags, and the tags could be the GUID of a Docker container. It could be the operating system that Docker container is running on. And then you have a field set, and the field set could be things like, what's the current CPU utilization of that Docker container? What is the current memory utilization of that Docker container? What's the network traffic of that Docker container? And then you have a timestamp, and the timestamp is in Unix time, so the number of seconds since July 1st, 1970, the start of the Unix epoch. So that's it. That's the format. So it's simple. It's super simple, super fast. And again, we're thinking in terms of, millions of metrics per second, it has to be fast. So to be able to persist, different types of Java objects, that's not something that we can do. One thing that we can do, however, is we can parse JSON and pull different metrics out of JSON. So if I look at Telegraph, parse, and so if the reason I mention this is that if you can convert your Java objects to JSON, then we have the ability to parse out that JSON and pick out, basically take that JSON object and convert elements of that JSON object into the line protocol that we just saw. So in that sense, that could be how you could go from, let's say, Java objects. I would go Java object, get that Java object, add it into JSON, and then use your parser to pull metrics out of your JSON object to go into the line protocol. Or that's one strategy. Another strategy could be simply, in your Java code, just simply write straight out to line protocol, and that would be simpler and quicker. It depends on your use case, depends how, your metrics per second that you want to ingest.
Awesome.
Yeah.
Okay. Some few more here. One of them being is, how does InfluxDB store the data when the data comes in every few seconds, but it's not frequently changing, doesn't change for hours? For example, like the status of a machine, like on and off.
Yeah, so we will, so in that case, let's say, so a machine turning on, machine turning off, what you'd probably want to do there is just track each state change. So, I suppose again, there's two strategies. One is you could, on a regular interval, let's say once a minute, track, is the machine on, is the machine off? That's one way to collect the data. The other strategy to collect the data, obviously much lower volume, is just to track the state changes. Like if the machine's on, okay, write one line of line protocol, it's on. 45 minutes later, let's say it turns off, boom, another line of line protocol turns off. That would be a lot more storage efficient. However, if that latter strategy is not available and you need to just simply check once a minute or once a second or whatever, what you can do then is you could then downsample your data. And so you could say, perhaps you could perhaps go ahead and say, in 10-minute buckets, was the machine on, was the machine off? Or in 1 hour buckets, was the machine on, was the machine off? You can also use Flux. If we look at InfluxDB, Flux state change, I believe we have a function. Yeah, so there we go. So if you look at Google InfluxDB Flux state change, then you can see here how you can monitor different state changes in your events. And so this Flux function allows you that. So you basically look for state duration, what column you're searching for, the value you're searching for, on, off, 1, 0. You're writing to a column called state duration, and so forth. So this is one example of why Flux is necessary. This would be difficult, if not impossible, to do in SQL. But with Flux, we already have. It's very extensible, so we can build in these different things that make things really easy to program with. So that's, again, a key. We get asked, why did you create a new language? We did because once you learn that language, you get a lot more power in that language. And state duration that the viewer is asking for is just but one example of that. So thank you. That was a great question.
Yeah, good to know. I'm sure that was very helpful for one of our attendees. It looks like we've got time for about 2 or 3 more questions here. Let's go with this one. Does a user have to use your AWS database, or can they set up a local instance?
Great question. No, they don't have to use our AWS database. They can set up their own local instance. So when you look at InfluxDB, you have a range of different products. You have our InfluxDB, our open source on-prem database that you manage yourself. Again, it runs in everything from Raspberry Pis, developer laptops. You can run it in the cloud if you want, run it on Docker. So you can use that. You can use InfluxDB Cloud, which runs on AWS, Azure, and Google Cloud. We also have InfluxDB Enterprise, which is on-prem, self-managed, but it's similar to InfluxDB in that way. You can run it in the location you want, but it runs in a cluster. So you do that for scalability. So these are the three different capabilities that you have that you can run. And InfluxDB Enterprise, of course, will run on a wide range. You could run InfluxDB. You could run InfluxDB on your own cloud infrastructure, run it on AWS or Google or Azure if you want to you want to maintain InfluxDB Enterprise, but you want to run it in cloud infrastructure, or you could run InfluxDB Enterprise on your own data center as well. So we give you a lot of flexibility in that regard. So if you want to go ahead and get InfluxDB, simple as just going ahead and going to the web page, and you can go ahead and download it yourself. You can also, if you're running a Mac, brew install InfluxDB is a super quick way to get it as well.
It's nice to have options.
Thank you.
So that's cool that Influx does that. And then our last question here is, a couple people are wondering is, how does InfluxDB compare to the Timescale DB, which is based on PostgreSQL?
Yeah, that's a great, exactly, great question. So with Timescale, I think one of the key things there to note is that the range of functionality that Timescale has is a lot less. Timescale gives you some level of deployment flexibility. You can run Timescale DB in the cloud. You can run it on your own. You can run a local instance of it. However, and it has rapid ingest like InfluxDB has. However, the challenge is that you don't get the ability to. You don't have all this built-in capabilities. You don't have built-in data exploration. You don't have built-in data processing. You don't have built-in data collaboration through notebooks. You get to query with SQL, just like InfluxDB has InfluxQL. And with our IOX project, we're also going to be allowing you to query SQL by about the middle of this year. But you don't get a more powerful language like Flux. With enrichment, if your metadata is stored in Postgres, great. Timescale will work phenomenally well for that. However, who uses just Postgres? And who wants to be limited to just Postgres? You might want to be able to use, MySQL. You might want to use SQL Server. You might want to use Maria. You might want to use Oracle, or you might want to use AWS RDS Postgres. You can use that with InfluxDB. You can't with Timescale. So with Timescale, even if you are 100% all in on Postgres, it doesn't work with all the various flavors of Postgres that are out there. Again, like AWS RDS Postgres. So your enrichment is heavily limited. We both actually Timescale in their in terms of ingest, their onboarding guide recommends to use Telegraph. So that's us. That's nice that they say that. We work with our competitors as well as we work with ourselves. But one nice thing when you use Telegraph is you have one vendor that handles both the ingest side with Telegraph and the data storage side, namely InfluxDB. So vendor consolidation, one throat to choke, single point of responsibility is something that you do not get with Timescale that you do get with InfluxDB. Dashboarding. With Timescale, you need to use a separate dashboarding tool such as Grafana. With InfluxDB, you can use Grafana, it works great, but we also have built-in dashboarding. Again, just one less thing to have to maintain. We have much broader alerting. We have pre-built templates. They don't have broad alerting. So yeah, there's a lot of advantages in terms of built-in capabilities that we have that Timescale simply doesn't have. One of the things Timescale talks about is, around performance. And one of the key things to look at is with our IOX project, IOX, we're really taking performance to the next level. And so, that's something that I encourage people to take a look at because we're rebuilding the core of InfluxDB. Again, everything will still work. The outer APIs will still work, but the core is going to become much faster, much better around cardinality. And so as a result, we're basically jumping onto the next wave using really technologies that have been open source technologies that have been developed in the last few years, as opposed to Postgres, which is a technology that's been around for decades. So we're really looking forward to taking advantage of the latest open source technologies that are out there with IOX, such as Rust, Apache Arrow, and so Parquet, and so forth. So definitely encourage you to take a look at IOX.
Yeah, that sounds super exciting. And it'll be interesting to see how you can take advantage of the ever-changing open source environment. And unfortunately, we are out of time today. Just so we can be respectful of everyone's times, we're going to go ahead and conclude things here. So with that, DZone would like to thank Al for a phenomenal presentation. DZone would also like to thank InfluxData for providing the audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Hope everyone has a great day.
Bye, everybody.